In this video, we're going to go through 8 types of question of vector, and I will write the given conditions in red color and then the solutions in purple color. So the first type of question asks you to find the velocity and acceleration vectors when given the position vector. So the velocity vector will be the first derivative of the position vector. And then the acceleration vector will be the second derivative of the position vector, and also it is equal to the first derivative of the velocity vector. The second type of question will ask you the position of a particle at a certain value when given the components of the velocity vector and also given the position of the particle at a particular time of t. So solve for the positions. We know the velocity equation is the first derivative of a position equation. So we take the integral of the velocity equations. Then the equation will be the position equations. But if we take the integral, we need to find out the value of c. So we plug in the conditions that the position at time t is a, b. Then after we plug in the condition into our integral, we will find out the actual value of c, and then we will find out the actual equation of position. So the third type of question asks us to find the velocity at a certain time of t when given the components of the acceleration vector and also given the velocity of the particle at a particular time of t. So basically, we first find out the velocity equation. If we know the acceleration equation is the derivative of the velocity equation, then we can just take the integral of the acceleration equation, and then it will be our velocity equation. So in order to solve for c, we plug in the velocity at time t back into the integral, and then we get the actual equation for velocity. And then we just plug in the time we want, and then we get the velocity at that time. The fourth type of question will ask us to find the slope of the path of the particle for a given value of t. We are given the equation of position of both x and y components. So the slope is equal to dy over dx. And then dy over dx is equal to dy over dt over dx over dt. dy over dt is the first derivative of the y components of position, and dx over dt is the first derivative of the x components of the equation. The fifth type of question asks us to write an equation for the tangent line to the curve for a given value of t. So to solve this kind of question, we only need to know that the tangent line of a curve is the first derivative of the curve. The sixth type of question asks us to find the value of t at which the line tangent to the path of the particle is horizontal or vertical. So to solve this question, we need to know the slope is usually dy over dx, and dy over dx is equal to dy over dt over dx over dt. So it is equal to the first derivative of the y component over the first derivative of the x component. So if the line tangent is horizontal, then the first derivative of the y component will be 0. And if it is vertical, the first derivative of the x component will be 0. The seventh type of question asks us to find the speed of the particle at a given time of t. So to find the speed, we know the velocity function is always the first derivative of the position function. So we take the derivative of the position function and then get a velocity function. So to find out the speed of the particle, we plug in the time t into the velocity function, and then we get the velocity of the particle in x and y component. The velocity will be the square root of the velocity in x direction squared plus the velocity in y direction squared. To understand why we use this equation, we can draw a little triangle. The last type of question asks us to find the distance traveled by the particle for a given interval of time. So the velocity is given in x component and y component. To find out the total velocity, we will use the equation in last question to find out the velocity first. And after we find out the velocity, we know the distance traveled equal to the integral of the velocity from time A to time B. So the distance will be the integral of the velocity equation from time A to time B.